Now, for my favorite part. You almost had Mardi Gras colors there. We should have a yellow, a golden, a board marker. Okay, okay. Oh, whoops. There we go. We just drilled away that camera now. So let's talk about, this isn't a standard name, is what I call it, argument strings. Argument strings. When I say that, what I mean is this idea. Arguments start with a true premise, right? And deduce the conclusion is true. Is it gonna focus? What's happening? What if, hopefully it'll just catch on. What if we use the true conclusion, there we go, as a premise in another argument? Oh, this idea is tasty. This is exactly where it's at. Like, I'm gonna write boom. This is the whole freaking thing. Ooh, we can make more colors. There we go. This is the whole freaking thing. Oh, can you? This is not the right time to not focus, camera. Can you? Oh, I feel like I almost had it. I was gonna draw squiggly lines till it focuses. It really doesn't work. Anyway, what it said last time I focused is that arguments start with a true premise and deduce the conclusion is true. What if we use the true conclusion as a premise in another argument, right? And then from that argument, you get another conclusion. And then you can use that conclusion in another argument. Then that leads to another argument, another argument. You can start stringing these arguments together and do really complex things. So, for example, consider the movie Good Will Hunting. Who's seen Good Will Hunting? No one?
What actors are in it?
Matt Damon, Ben Affleck.
Is it the really is it the really smart dude? Like he's really good at math?
Yeah, man. Matt Damon's
Pretty sure I
janitor's
saw
really good at
that.
math.
Yeah.
He's my inspiration. Anyway, yeah. So to the movie Good Will Hunting. Now we're gonna have some givens about it. Like, let's just say for some reason you know these following things to be true. First given, A. If a movie has Matt Damon or Tom Hanks, then it is good. Fact A. Fact B. If a movie has the actor Rob Schneider, it's is bad. C. I'm sorry, no, not is bad. If a movie has the actor Rob Schneider, it has multiple fart jokes. I've seen Rob Schneider, that's his style. C. Good Will Hunting has Matt Damon and Ben Affleck. I might be spelling that right. And D, if a movie has multiple fart jokes, it is bad. So these are your givens. We're going to consider these to be facts. And here's the claim we're going to try to prove true. Claim. Our claim is that Good Will Hunting does not have Rob Schneider. So, from just these facts, nothing else in the world, we're not going to use anything else. From just these 4 facts, we want to prove that Good Will Hunting does not have Rob Schneider. So, first of all, let's just look at it. What do you guys think might be kind of the direction we're going to go here with this proof?
I think there's 2 ways. I think you could use A and C, or you could use B and D in like a negation sort of way.
I think it's going to use all that. So notice that Good Will Hunting has Matt Damon and Ben Affleck. That means in particular it has Matt Damon. And then if a movie has Matt Damon or Tom Hanks, then it's good. Since Good Will Hunting has Matt Damon, therefore Good Will Hunting must be a good movie. Notice down here, if a movie has multiple fart jokes, it's bad. But Good Will Hunting's not bad, it's good. So what can we say about it?
It's not D.
Well, D is just saying...
Or D is not true, rather.
So D, these are all assumed to be true. These are your givens, right? So by given, I mean assumed to be true. They're not true because there are premises, they're true because they're a given. So assume these to be true. So D is true. Exactly. Thank you, Sid. So Sid said if a movie has, or Siddhartha said, I'm sorry, if a movie has multiple fart jokes, it's bad. By contrapositive, that means if a movie's good, then it does not have multiple fart jokes. It has at most 1 fart joke, which Good Will Hunting has. It's a great joke. The point is, so by D, since we know by A that a Good Will Hunting is a good movie, it's not bad. Therefore, it has at most 1 fart joke. It does not have multiple fart jokes. But if it doesn't have multiple fart jokes, it can't have Rob Schneider. Because if it had Rob Schneider, it would have multiple fart jokes. That's going to be the direction. I hope that makes sense. Let's get mathematical and prove it. So the first thing we're going to do is we're going to clean this all up by making some notation for all this stuff. So I'm going to say that MT, where's all my notation here? Actually, let's write on a piece of paper. Let's get a piece of paper. All right. So we're going to say that MT, or M, M is going to mean that a movie has Matt Damon. The T is going to be that a movie has Tom Hanks. B is going to be that a movie has Rob Schneider. I'm sorry, that's going to be R. R is going to be a movie that has Rob Schneider. B is going to be that a movie has Ben Affleck. G is going to be that movie is good. And then finally, we're going to define big F to mean movie has multiple fart jokes. You can tell I'm taking this seriously. Yes. So these are we're just going to use these letters to make all of our notation simpler. So if we have all of this, right, based on our new notation, how can we rewrite A? Actually, I'll write it down here so you don't miss anything. So then A is going to be, if a movie has Matt Damon and Tom Hanks and it's good, what that's saying is that if it has Matt Damon or Tom Hanks, that implies it's good, right? If it has Matt Damon, T has Tom Hanks, then it's good. B is going to be, B says if a movie has Rob Schneider, has multiple fart jokes. So that's saying if R, then big F, because R has Rob Schneider, big F has multiple fart jokes. C, that's going to be go ahead, Matt Damon and Ben Affleck. So what we know about this movie is that both M and B are true. The movie has Matt Damon and it has B, Ben Affleck. And then finally we have D, which is if the movie has multiple fart jokes, then it's bad. So that is F implies what?
Not G.
Exactly, not G, because G is good, so not G means bad. There we go. So now we've written all of our stuff like this, just to make it a little simpler. And we have that we can write our claim. Our claim is now saying that Good Will Hunting does not have Rob Schneider. So our claim is not R. So what we're saying is that based on these four givens, we can prove not R. So any questions about what we're doing? Okay, good, because I'm going to erase to make some more space. So I'm just going to rewrite these. So A then is M or T implies G. B is R implies F. C is M and B. That's an R. There we go. And D is F implies not G. And then our claim is not R. So, proof. Let's string all these together. So these, let's string all this together to make a proof. I think if we keep writing in focus, let's just keep going. So if we're trying to prove not R, what's the first thing that we should do? What's the first thing we said we could do?
We could try to prove that the movie is good, and if the movie's good, it doesn't have Rob Schneider then.
Exactly. We're on that track. So trying to prove the movie's good. So in order to prove the movie's good, it's really, really nice to know that the movie has Matt Damon or T. M or T is true. But we don't know M or T straight off the bat, but we know that M and B is true. So let's start there. So we have M and, can you please focus, camera? I'm going to fix this soon. So if you have M and B is true, and this is by given number C, or given letter C, what can you conclude?
That the movie's good.
Well, not quite. We can't jump to that conclusion yet, right? Because right now we only know that M and B are true, but nowhere here does it say that if if M and B are true, that implies G, right?
The
Can we go to
movie.
statement A?
You have to get to A first, exactly.
Yeah.
See what I'm saying, Safa? Because now, if we had a claim that said like M and B, then G, then you're totally good. We could do that. But we don't have that claim. So we're trying to use just the things in here. And so in order to kind of get the movie's good, we have to get to A first. So we can conclude M. And what argument form tells us we can do that?
Isn't that specialization?
Specialization, exactly. Good job. 50 points, Safa. There we go. Yeah, exactly. Specialization. It just says that you have M and B, you can conclude M. So now, since we know M and B is true by C, we know M is true, right? That's what we're concluding. M is true. So now we can use M as a premise in another argument. Specifically, in order to use A, what do we need to prove?
One of the two is true, so because we know Matt Damon is true.
Yeah, and
Just
I
say.
we use capital T for truth, so I'm going to call Tom Hanks the lowercase t. But anyway, yeah, exactly. In order to use A, we need to show that M or T is true. Okay, well, let's say here. We have M. We have M. And actually, I'm going to label. I'm going to label this first argument 1. And this is our second argument, which is 2, or second, like, little tiny argument. So we have M by the conclusion of 1, right? We can say we have M. And then, therefore, we can conclude M or T by what?
Generalization.
Generalization, exactly. Generalization. And then, yeah, so that's just that. So now we have M or T is true. And now that we have M or T by 2, and we have M or T implies, G by A, what can we conclude? This is the whole thing, right? That's what we're trying to get at.
We can probably conclude D, or we can go to D.
Well, remember that these are A, B, C, D. They're all assumed to be true. We know these to be true. What do we got in the chat? G, exactly. If you know M or T is true, and you know M or T implies G.
Well, G is true.
G is true, exactly. And what's this by?
No, it's
What do we got? What was that thing called? We have
modus ponens.
modus ponens, exactly. That weird. You guys had your chance to name it, but you chose not to. That's modus ponens, exactly. Modus ponens is when we prove this argument form is valid, meaning if we have these two premises, which we know are true by 2 and A, then we can deduce conclusion G. All right. Now 4, what should we do next? So we know the movie's good. That's great. We're that far. We want to eventually prove it doesn't have not R is true. I want to prove it doesn't have the Rob Schneider. And actually, I'm going to change this capital F to a lowercase f for the exact same reason with the T, because big T and TF, big F are the two letters I couldn't use, and I used them both. But anyway, the point is, now that we know the movie's good, someone said we can go to D. What can we do with D?
Oh, can we use the division into cases? Maybe?
Division into cases. I don't think we even really need that here. I think, look at this. If you know that F implies not G, what else do you know? Like, what's equivalent to this?
Could it be G implies not F?
G implies not F.
So contrapositive?
The contrapositive, right? But we already have a rule that uses this. So let's say we use the fact. So if you have the G implies not F, we know G is true. That means that not F must be true. So, but the way we can write that is we can say that F implies not G by D. And then we have G by E, or not by E, by 3. 3 is already proved G. So what can we conclude from these two things? We just kind of said it.
Not G implies F.
Yeah, we have not G imply, sorry, oh no, we can't say that not G implies F. That's the converse.
G implies
Yeah,
not
G implies not F, right? So therefore, we have not F. And this is by modus tollens. So remember, modus tollens, what it did is it said that if you have an implication and you know the conclusion's not true, you can prove the hypothesis must not be true by using the contrapositive law. We use that in our proof, right? But this was just exactly what modus tollens said. Because remember, G is really equivalent to not G. And so by 3 in the double negative law. So you look at modus tollens and you'll see that's what this is, right? It's just taking an implication. You have the implication and you have that the conclusion is not true, the conclusion of the implication. Then you know the hypothesis must not be true. That's all modus tollens says, and we proved it, so we can use it. So this argument form is valid, so therefore not F is true. So, or F is not true. So we're almost done. So we have that not F is true by modus tollens. Let's go up here and do one last little bit. So we're trying to prove not R. So what given here do you think we can use to prove not R?
Probably B.
Same thing for B.
Yeah, B, right? B is saying that if you have R, then you have F. Well, we know we don't have F, therefore we must have not had R. That's modus tollens. We have this implication here. We know the conclusion's false. We know the conclusion's not true. We know the conclusion's false, and F is not true. Therefore, by modus tollens, we can conclude R is not true by using the contrapositive, basically. So we have R implies F by B, and then we have not F by 4. So therefore, we can conclude not R by modus tollens. Square, because we are done. There we go. We just used, right? We just used just these 4 givens in logic to prove Rob Schneider must have not been in Good Will Hunting. That's our conclusion. Any questions on that? So you see how we can string these arguments together like this and use kind of the conclusion of one argument as the premise of another argument, and then we can use You know, we can kind of use multiple conclusions and put them together as another premise, and you get another argument out. And we can combine these in weird, interesting ways to prove a ton of stuff. Does this make sense what we did here? I hope so. I think every single one of these steps is easy. All you gotta do is put them together. And yeah, and then notice that this is the format we're going to use for proofs. Notice that every single line we have a justification. We have this by C. We have this by specialization. Every single line we say why we know that's true. And a lot of these we say it's true because of something we did before. Like here we know this is true because of what we did here. Here we know it's true because we did here. So yeah. Any questions on this? Okay.